Welcome to the Rich Report, a podcast with news and information on high performance computing. Today, my guest is from DDN. We have Laura Shepard. She is the Director of HPC Markets at the company. Laura, how are you today?
Doing great, Rich. How are you?
Well, great. We're recording this ahead of supercomputing. I think we can reveal that. But it's really creeping up on us fast, isn't it?
Oh, it certainly is. We're heads down over here.
Yeah, yeah. So lots of announcements. So why don't we just get into it, Laura? I've got your slides up, and it starts out, looks like, an overview of DDN, the company.
Right, just a couple of slides for setting the context rather than jumping straight into the announcements. So we're talking about kind of the company structure for those people who may not be familiar, that we've been around since '98 and focused on data-intensive environments for the entire life of the company, that we're the world's largest private storage company, and that we're experiencing significant growth in our market space. We're profitable and self-funded, and headquartered on the west coast of the United States, but with presence around the world. We're doing a lot to expand our presence internationally, not only adding new offices for sales and marketing, but also for engineering development, benchmarking, and also partner benchmark facilities so that people can come in and try our products in conjunction with some of our larger OEM and reseller partners as well. So you're seeing us go to a lot greater depths around the world as well. Just wanted to start up at the portfolio level and talk about the end-to-end portfolio so that we can then talk about each one of the announcements and where it fits in. We're in very good shape with an end-to-end product portfolio right now that addresses the toughest problems in data-intensive environments, from dealing with massive increases in compute to how to manage high-performance data, to cost-reducing data in active archives, to sharing, collaborating, distributing data in private and hybrid cloud environments, and being able to do all of this with a unified data layer so that applications and users, administrators can have the same view of data regardless of where it sits. So to that end, our entire portfolio now works together in terms of being able to view and also migrate data amongst different tiers of storage so that people can have the right type of storage product, be it the high performance for Scratch, burst buffer data, or object storage for archive and cost reduction, all being managed by the same set of tools and the same people. So with that in mind, we want to kind of show a quick view of what a high-end customer might be implementing today, somebody who's dealing with massive amounts of data growth, using the entire portfolio end-to-end, and being able to use their data from the burst buffer all the way through the high-performance layers, the archive layers, the remote layers, and even to the scale-out NAS. So I want to give a quick business update. Today we announced our Q3 15 financial results, and it was the biggest bookings quarter in the company's history. So we had quite a record, and then we also are going strong into Q4 of 15 with good backlog and a very large pipeline. And a lot of this growth is coming from not just our traditional markets in terms of academic research, national laboratories around the world, etc., but increasingly our highest growth is coming from our crossover markets and our true commercial HPC markets. So web, cloud, and telco, and also enterprise HPC like commercial life sciences, pharma, pharmacogenetics, etc., oil and gas, financial services, and increasingly also manufacturing. So the largest portions of our growth are coming from these more commercial spaces than were historically. So into this context, we want to talk about a new product that we've built on top of our WAS, which is our object storage platform. And the new offering is called WAS Enterprise Protect. And what Enterprise Protect is a feature set that allows IT managers to control their data while remaining inside corporate policies or even legally mandated guidelines, while allowing their users in offices or mobile to collaborate and share data across all different types of platforms, operating systems, and devices in a really cost-effective cloud infrastructure. So just going to start with some basics on WAS for those of you who may not be familiar with our object storage offering. So WAS is a true no-FS object storage. That means there's no file system infrastructure to house, so you get to use the maximum amount of every piece of storage that you purchase to put in the infrastructure. It makes it a very cost-effective way to store massive amounts of data. Object storage also has a great number of scalability characteristics which make it very beneficial to large-scale environments. So you have a cost-effective platform that's very good at large scale that we built initially for very high-scale Web 2.0 types of environments and have since added a much richer feature set so that now even small implementations can take advantage of our offering. We have providers who use WAS to build infrastructure to roll out their own software as a service, to roll out content distribution networks, and other third-party offerings. We have a lot of direct businesses using WAS to build private clouds, to build hybrid clouds, to get them ready to stage data into public cloud environments as well. And with this type of approach using WAS and its highly efficient delivery of an increased percentage of the storage platter, they get very nice TCO benefits versus outsourcing their cloud infrastructure. For the developers, we have a very robust set of APIs for them to be able to attach applications to the platform and also in and out of the platform. We have gateways to use standard networking protocols like NFS and CIFS. You can also move data through the system using S3 and other interfaces as well. End users like the platform because they can use its very robust search capabilities. And you can search through data on a lot of different dimensions. This is becoming increasingly interesting as people look for ways to get value out of large pools of non-traditional data that might have a much greater longevity in an organization than they would have historically. So in other words, multi-data source analytics. And from an administrative standpoint, it's quite simple. Either you're using our WAS in conjunction with a file system-based offering where you can view all the data through the file system, or you're managing it as a NAS, or you're managing it from an application layer talking to the API. So these are some of the core benefits of the platform. And we've been developing this since 2008. And now WAS users represent something over 200 billion objects in production environments. So this is a very large and robust offering. And now on top of it, we're starting to offer additional features for broader enterprise applications. And that's where Enterprise Protect comes in. So as we start talking to people about WAS Enterprise Protect, of course, they also want to talk to us about the basics of object storage. So we look at having to explain the benefits of the object storage solution versus other traditional storage options as well as other object storage-based offerings. And so for ours, for WAS, we generally tend to have a lot of discussions on security, accessibility, efficiency, reliability, performance, and scalability. And these are the areas against which we get compared. We have a very nice white paper where you can see all of the features and benefits in each one of those areas on our website. And in addition to this platform, we've now added our WAS Enterprise Protect features. So for those customers who want not only to have this, efficient, scalable, object-based infrastructure, they want to be able to offer compliance or corporate governance compliance features on top of it, backup, file sync and share, data protection, collaboration, and to be able to control mobile data as well. This is what WAS Enterprise Protect lets them do. So in the product, you have endpoint backup, file sync and share, very sophisticated WAN optimization, and features for data governance, including simple integrated policies for legal hold, e-discovery and compliance features, deduplication, and support for heterogeneous environments and devices, multiple operating systems as well as multiple devices, and the ability to secure data with a remote wipe option. So if one of those mobile devices goes missing, it doesn't necessarily put your data at risk. IT can also control user-specified data protection levels, which is something that is important when you're looking for an enterprise data protection solution. So with our new WAS Enterprise Protect, IT managers get to control their data in accordance with compliance policies that may be in existence today or ones that are coming down the pipeline, while providing an environment in which their end users can collaborate and share data across multiple platforms in a secure and cost-effective cloud infrastructure. So that's it for WAS Enterprise Protect today. I'm going to move on to the DDN 14K platform, which we're announcing November 10th. This is going to be the highest performance, most scalable, lowest latency platform in the industry. And we're going to be discussing it along the axes of the individual components within it, as well as what the entire system achieves together. So when we look at how storage development goes in the marketplace, we have to look at what the customer's changing data requirements are. And historically, you've seen faster components emerge to help ameliorate the fact that the rate of data growth and the rate of computational performance growth has always outstripped the rate of performance growth in storage media. So there's been this gap, and it's been getting more and more disparate. And now you also see that you have a lot of data mounting that the ability to manage this disparity is becoming more difficult. When you add to that the changing requirements of the end users in terms of how much data they want to be able to take advantage of, let alone harness and generate, that disparity is becoming rather remarkable. So as data grows and more data sources come online, which people want to exploit from an analysis and collaboration standpoint, this disparity between processing speeds and the speed of storage media is creating a wider and wider gap. It's harder and harder to bridge with interim technologies or just the latest, fastest drive. The sheer amount of data is also surpassed a lot of organizations' ability to harness in an effective way and reuse in terms of not being able to just solve this with latest, fastest drive, the largest drive, or bursting to a public cloud infrastructure. When we looked at an evolutionary approach to these problems, there's the do-it-yourself. I'm going to get the latest and greatest, highest capacity drives, the fastest solid-state drives, the fastest memory controllers, et cetera, and I'm going to put them all together myself. And I'm going to optimize as much as I can, and I'm going to support it. Or you can do the approach that we've taken in the SFA 14K, which is to take each one of these newest components, add additional acceleration to them through unique capabilities that we offer, and then converge them into a single infrastructure that allows you to balance them and harness the full potential of each component. So we're taking the fastest solid-state drives, we're taking the latest interconnects, and we're embedding all of this with the latest networking. We're accelerating the drives, and we'll talk about that in a second, with our own caching capabilities, and unifying our data end-to-end, and virtualizing applications so that they can sit resident with the data. And when you take applications and file systems and you make them co-resident with the data, you also remove a huge amount of latency. So yet another performance addition. So what this gives you is a single point of support with a huge amount of reduction in the terms of the number of components that you need to source and manage. So this is a convergence benefit. Also a simple way to incorporate new technology and to add newer technologies as they become available, which all translates to a very high performance capability that also reduces cost of management. So this is our approach to the base platform, which then gets productized in a couple of different ways. One is the SFA 14K, which we're announcing today. Another is our scale-out NAS implementation based on this same platform. And the third is our all-flash array, which is based on the same hardware platform, further accelerated by our infinite memory engine and based on an all-flash capacity. So they go into some detail on the SSA14K. This is the world's fastest hyper-converged storage. We say it's the fastest, the densest, and the simplest at scale. And the rest of the material here will go to describing the product along those lines. In 4U, you get a 60 gigabyte per second system that can also deliver 6 million IOPS. So from a performance standpoint, that is something 2 to 4 times industry published numbers for current systems, and well beyond that when you do a direct comparison for the majority of the systems in this space. So it is the fastest. It certainly has the highest density at around 7 petabytes in a rack. And with 6 million IOPS, that's a nice alternative for people who are dealing with a lot of mixed I/O or IOPS-intensive workflows. We say it's the simplest at scale because you can build the building block that you want to achieve the goals that you have in your organization today. Rather than tying you to a lot of controllers to a small amount of disk, you can size each building block the way that you want, scaling up or out. There's a pay-as-you-grow model and gives you fewer systems to manage, which of course is more cost-effective. So let's start getting into the details a bit more. We give overall bandwidth numbers and overall IOPS numbers, and it's nice to get some context in that in terms of comparing to other products in the marketplace. If you look at transactional performance, i.e. client IOPS, you're going to see against some well-known names, even all-flash, that the SSA14K is well ahead from a performance standpoint. Same thing with streaming bandwidth. In terms of total system throughput, you're looking at several X any type of leading competitor in the space in terms of pure performance. Let's talk a little bit about scaling up and scaling out, because we're going to talk about our scale-out NAS implementation on top of this platform next. So when we're talking about scaling up or scaling out, the flexible building block approach is very appealing, especially to people who are starting small but are going to grow very quickly. And also those people who are starting very, very large and want to deploy fewer building blocks to manage to begin with. So being able to have the flexibility to drive an entire rack of up to 7 petabytes worth of storage off of a single controller enclosure has a lot of benefits for people in either one of those situations. First of all, you know that you have the headroom to grow. Second of all, you can start small and pay as you grow, and the solution gets less expensive as you grow because you're just adding drives. Third, from a TCO standpoint, you have the added benefit of having the highest ratio of drives to controller of any type of product you're going to find, and therefore the cost of powering, heating, and cooling that system is going to be much lower. And then when you think of the industry-leading density of the product as well, you have fewer floor tiles overall, not just for the performance, but also for the density, which means that you can deploy more and more systems in a highly space-constrained environment, and you also have a lower cost of space in the data center. Fewer pieces in the hyper-converged platform means fewer components to purchase and manage, and that also has a lot of TCO benefit. The fastest, the densest, and the simplest at scale. Now, when we look at what else we can do with the SSA14K, we can build on top of it. We can build a scale-out NAS on top of it. We have a lot of customers in commercial HPC as well as traditional HPC who have really reached the end of being able to use traditional NAS or traditional scale-out NAS in the workflows where they run their business. So in a financial services organization where they're doing algorithmic development and back testing against multi-years of market tick data, or even across multiple markets. In oil and gas where they're running multiple processing workflows concurrently. In traditional HPC workflows like research genomics, needing to be able to catch the data and process the data from multiple high-performance sequencers or other high data rate instruments these days. Any one of those has completely exceeded the capability of a traditional network-attached storage implementation to deliver the performance that they need. This being the case, there is a lot of demand for the same type of simplicity of building blocks, of ease of management that a traditional NAS or traditional scale-out NAS would offer. But the performance that you see in something like a parallel file system-based storage area network that would be typical to an HPC environment. So when you look at the set of requirements and the number of workflows that really need it in order to do their work today, this is where a DDN, parallel file system appliance, makes a great scale-out NAS. We have parallel clients that allow the systems to access data much more quickly, so that front-end networking is no longer a bottleneck as it is in traditional NAS and scale-out NAS. Because we don't have a clustered OS on the back end, any type of inter-node communication issues do not impact performance because they don't exist in the new scale-out NAS based on the SFA14K. So you don't have any back-end issues in terms of inter-node communication and delivering data. When you see a drive failure, which is going to happen when you're talking about really large systems, the amount of performance that you lose using this approach is very small versus a traditional or scale-out NAS. So we talked about the front-end networking bottleneck, and now we've talked about being able to scale up and scale out independently. Another benefit that the scale-out approach from DDN brings is that we can embed the parallel file system within the storage controller, which means we reduce a great deal of latency and really are able to increase performance for the end user. So while you can use your own parallel file system, or we can have it outside the system as well and build that for you, one of the great performance and manageability benefits is by converging the file system also inside the device. We do this at the factory and configure the entire thing so that it comes to the end customer with a lot of those usability and manageability benefits that they're used to from a traditional NAS or scale-out NAS environment. So what you've got is a platform that solves the front-end bottleneck of a traditional scale-out NAS, that solves the back-end performance issues of performance during outage conditions, and that scales. It's actually simpler at scale than a traditional NAS or traditional scale-out NAS, where for every increment in performance or capacity, you need to add an entire other system with its own set of connectivity and management issues. Here again, that scale-up or scale-out building block is very useful in terms of being able to size the NAS whichever way you need without having many, many devices to manage. So we talked a little bit about the end-to-end product portfolio at the beginning. Now, when you take a new scale-out NAS from DDN, and here the example we're using is our GS14K. That will be our grid scaler 14K. You can combine everything that you need for the entire end-to-end HPC or commercial HPC workflow in a single rack and have everything work together, or you can mix and match your components as you like. So having a GS14K serving your CIFS, NFS, and parallel client traffic, as well as other protocols like Cinder, et cetera, to get data in and out of the system very quickly. And you can have that tiering with your WAS nodes for active archive, for enterprise management, et cetera, for private cloud, and for remote backup. And you can also have the same view covering even your teach systems, so that all of your data is present in your system, resident on the type of storage media most appropriate for the type of performance access you need for it and the type of cost profile that is suitable for its value to the organization at a given time. That's automated and policy driven. So when we have these environments who are running into the wall in performance with traditional NAS and traditional scale-out NAS, and instead offer this type of alternative, suddenly they can take a high data rate instrument like a microscope or a sensor that's generating huge amounts of data and give it access to the GS14K at gigabytes per second per connection, and put as many of these on as they need to before they need to scale up any additional systems to manage. This is a huge benefit in terms of how they can run their business more cost effectively and more reliably, because they're not going to run out of performance and miss capturing some ephemeral event that affects their bottom line. So the SFA14K based parallel file system appliances really can be the new scale out, solving the problems of traditional NAS and traditional scale out NAS. So with that, I'm going to move ahead into IME. So the IME14K, this is our infinite memory engine all-flash array, also based on that same hardware platform that gives us all of our hyperconvergence benefits. And now we're talking about taking the 4U base system and giving full bandwidth access to multiple SAS-based SSDs or NVMe-based SSDs in a system that gives Intel Haswell CPUs today and is ready for the next transition as well. So there are quite a few all-flash arrays on the marketplace. And certainly it is good to take the latest technology and make it available as fast as possible. But with DDN's all-flash arrays, we add acceleration on top of the latest media in order to take maximum advantage of it. And in the 14K, we're able to converge that on incredibly fast networks as well. So let me tell you a little bit about IME so that you understand what type of acceleration we're doing on top of the industry's latest SAS-based SSDs and NVMe-based. So with IME, IME is a layer that sits between compute and storage and turns problem I/O into very smooth I/O that could be consumed by the storage system. This is a huge bottleneck in high-performance applications. Every time you have a mixed I/O, a very small I/O application, you're going to hurt your performance a great deal. We have an example here of somebody using an S3D application. So this is a physics application that is used in modeling ignition. Very complicated and writes a huge number of small files, has a lot of fragmented I/O in its profile that slows down parallel file systems. So here you have a situation where the traditional technology, file system, parallel file system, has become the bottleneck. And it has a lot to do with contention in file system locking, in this case, such that there was infrastructure in this particular case that should have been able to be run at about 50 gigabytes a second, but the customer was only getting 4 gigabytes a second because the parallel file system could not handle the misaligned LIO. By putting IME in front of that application, could accept all of the I/O from the application directly into the burst buffer. And the burst buffer IME then aligns all of the I/O, writes it out to the parallel file system at very close to line rate. So without making any changes in their application or in their hardware environment, the customer is able to achieve the full potential of their hardware. This definitely is applicable when you're talking about the latest and greatest speed drives like NVMe, for example. Being able to take advantage of it relies on a couple of things. One, having the proper underlying hardware structure, making sure that you have provisioned to allow in the hardware infrastructure full use of all of those drives, regardless of what request type that you get. Number two, making sure that you are not that you're providing full bandwidth requirements to it from the front end too. What is going to be requested of it through the front end of the system, and this is where IAE comes in. So with the SFA 14K based infrastructure, with the full provisioning for SAS-based SSDs as well as for NVMEs, we've solved that on the hardware side. With IME, we've solved the contention problem on the front end so that you have a balanced system that can maximize the I/O that you should be getting out of these newest, latest drives. So some other ways that people are using IME today, they're using it, of course, as a burst buffer, and it's often referred to as a burst buffer technology. So if you have a bursty workflow, like checkpoints being the classic example, you would use IME to catch all of that I/O without having to purchase infrastructure to that peak requirement. So suddenly, when considering a new system, you don't have to size your storage infrastructure to the peak output of that system during that bursty workflow. It's a huge cost savings. File system accelerator. If you have identified the file system, the parallel file system, as the biggest bottleneck in workflow, then IME is a wonderful way to approach resolving that by realigning I/O as we described in the example given. An application optimizer. If you have an application that you've identified as being particularly having a particularly high I/O blender effect, IME is very good at smoothing this out. And also, as a core extender, being able to size the performance of the system, even when you're talking about catching I/O from a single environment with multiple supercomputing clusters, IME can smooth out the requests of the I/O so that even a shared single storage system can provide the necessary bandwidth for multiple systems in a single site. So those are just some examples of use cases for IME. So that brings me to the end of my slide. So Rich, do you want to jump in here?
Absolutely. Thank you, Laura. I guess first question is about availability for the three things we've talked about. So let's start with the WAS for the enterprise. When will that be available for customers?
So that's announced tomorrow, and that will be available this quarter, as will the 14K and IME. The scale-out NAS implementation is going to be available for the 14K in Q1 of next year.
Terrific. So, as DDN expands its capabilities, I'm wondering about traction. You mentioned that WAS has, lots of objects out there. Are you seeing take up in a broad set of verticals for that particular product?
Yes, it is being taken up in a broad set of verticals. Mm-hmm. It started out in web, obviously, and now we're seeing a lot of uptake in traditional HPC and beginning to now uptake also in commercial HPC, which is very exciting.
Yeah. So, as most people will be hearing this, it'll be supercomputing time, right? And will you be showing all these things in your booth this week at the supercomputing conference?
Yes, we have, I believe, 10 demo stations in our booth.
Yeah.
And it's very ambitious, so please come by and visit. Take the tour.
Well, terrific. Well, Laura, this is it's great to get a chance to catch up with all the things that DDN has going on, and I want to thank you for coming on the show today.
Okay, thanks for having me.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.